Hey guys, this is going to be the first in a series of videos I'm going to call Unscrambling Algebra. And I'm going to call it that because I've noticed some difficulties some students have with understanding exactly what they're doing when it comes to uh, the steps that we perform in algebra, mostly why exactly we're doing certain things. So I definitely wanted to go over some of these steps. So today we're going to address the fundamental question of algebra, and that is, what exactly does solve for x mean, and how can we solve a lot of these equations without necessarily doing a tremendous amount of work in terms of the algebra steps? And also, in further videos, we're going to address why the steps work the way they do. So all of this is aimed to further your understanding of what algebra really is, what the purpose is of many of your steps, and hopefully it'll make you understand some of the more complex concepts in a little bit of a different light. So the first thing we need to address is this solve for x. And probably the most important thing in algebra is to understand that solve for x means find the value of x, or values, that make the equation true. And at its heart, that's all that algebra is finding a value or values of a certain variable that will make the equation true. So let's consider this first really simple example I have here, that x plus 5 is equal to 12. Just think, without necessarily doing any of the algebraic steps, what value, if I were to sub it in for x, would make that true? And the answer should be fairly obvious. X must be 7. Because if I replace the x with a 7, then 7 plus 5 is equal to 12. Now, this is a really simple example. We're just going over a couple of concepts here. So if you find this very, very simple, don't worry, it's going to get a little bit tougher. So the next step here would be something like the second equation. Well, we got 15 minus x is equal to 9. And again, the question is really asking 15 minus what equals 9. And again, this answer should be fairly simple. X must be 6 because 15 minus 6 is equal to 9. So therefore, x in this particular equation, equals 6, and the one above is 7. So now that we have this idea here, we should be able to take a look at a somewhat progressively more difficult equations and see if we can figure out these solutions without necessarily performing the algebraic steps. So let's take a look at another example here. 2x plus 3 is equal to 15. Okay, so if you've taken an algebra course, you know what to do here, but let's try to figure it out without doing the steps. Well, in order for this to be true, what does 2x have to be? Well, then the question becomes, what plus 3 is equal to 15? And that answer is 12. So 2x must equal 12 in order for this equation to be true. Well, if we know that to be the case, then 2 times what equals 12? Well, 2 times 6 is equal to 12, so the answer here must be that x equals 6, because if we were to sub this back in, that checks out. So let's try a couple slightly more complicated ones here. Again, I'm going to make these progressively more difficult, but the concept remains the same. We're looking for the value of x that makes this equation true. So the next equation that we have here is x plus 4 all divided by 5 is equal to 6. And of course, we need to remember that the fraction really means a division. So then, again, I'm going to take the same logical step here. What does x plus 4 have to equal? In other words, what divided by 5 equals 6? And the answer to that is 30, because 30 divided by 5 is equal to 6. So x plus 4 must equal 30. Then the next question is, what plus 4 equals 30? Well, in order to get 30, when we add it to 4, x must be 26. So x equals 26 is a solution to this equation. Now we can check that work here. 26 plus 4 all over 5 is equal to 6. We get 30 over 5 is equal to 6. And of course that checks out. Now let's consider some other operations. X squared is equal to 25 is a square operation. So the question then becomes, what number squared equals 25? Okay, we should know from basic times tables that 5 squared is indeed 25. So the answer here is going to be x equals 5. But wait, there's another number that if I square gets me 25. Let's remember that a negative times a negative, of course, equals a positive. Okay, and in this case, it would be negative 5 times negative 5 is equal to positive 25. So negative 5 squared would also equal 25. So in this case, we actually have two solutions, because both x equals 5 and x equals negative 5 would yield true equations. So now let's combine a couple of things here. Let's look, for example, at the next problem here, where we have x squared minus 10 is equal to 6. So again, let's just kind of isolate this portion of it and say, okay, what minus 10 equals 6? And the answer to that we should know is 16. So x squared must equal 16 in order for this equation to be true. Well, if x squared must equal 16, then the question is, what squared is 16? Not what is 16 squared, but just like the last problem, what, when squared, is 16? And that answer is going to be 4. But of course, we can't forget that if we square negative 4, we will also get 16. And again, we can check these answers. 4 squared minus 10 equals 6 gets you 16 minus 10 equals 6, and that checks out. Negative 4 squared minus 10 would be 16 minus 10, and that also equals 6, so that checks out. Those are the only two numbers. Just like in every other problem, what we have found are the only numbers that would make these equations true. All right, folks, I got two more here. Let's check these out. We have the square root of x is equal to 9. So again, remember, the question is, what can I replace the x with to make this true? I am not saying that x is the square root of 9. I am saying what number, when square rooted, equals 9. And again, from just times tables here, we should know that the square root of 81 is equal to 9. Therefore, x must equal 81. Now, it's also important to note that negative 81 does not work. because the square root of a negative number, that's not a real number. Those are imaginary. So we can't take the square root of a negative number and produce a real answer. So square root of negative 81 does not equal 9. Don't confuse the two here. Again, you can always check by substituting the number back in. All right, now the last one here is a little bit more complicated. But again, we can use the same process here. So let's think about this. What does this have to equal in order for this square root minus 4 to equal 5? Well, the square root of x plus 3, in order to make this true, must equal 9, because 9 minus 4 is 5. Okay. Then we can say, okay, well then what does x plus 3 have to equal? In other words, the square root of what equals 9? And again, from the previous problem, we know that that's 81. So then x plus 3 must equal 81. And then finally, what plus 3 equals 81? And it's as simple as subtracting the 3 from the 81. So 78 must be our x. Now we can check this by substituting this back in. Okay, this is rad 81. Rad 81 is 9. And that checks out. Thank you for watching. We're going to have a few more videos in this series. Hopefully, we'll be able to cover most of the important topics in algebra and hopefully clarify some of these things that to make sure that you understand that they're not just processes, that they serve a purpose. Thank you.